Okay, good morning everybody and welcome. We're going to discuss the accelerated universal CPE powered by Modularity, brought to you by Silicom. So for those of you who do not know Silicom, we're an OEM originally out of Israel, publicly traded in the NASDAQ, been around for over 30 years. And we specialize in hardware designs and I would say combining a few different technologies such as FPGAs, ASICs, and the like. 350 employees, about $130 million annually. So the agenda for today is to speak about, first of all, what have we done during 2018? It was a very exciting year for us. And then a few steps forward. A lot of the people that came before me here, and I'm very glad they did that, so thank you, spoke about FPGAs, ASICs, and how to combine new technology inside the CPE, inside the edge, far edge, near edge, whatever you want to call that. There are a few new names now. And we're going to talk about that. On the one hand, FPGAs, and on the other hand, security tools for the edge. Because we all know we want to secure the edge, especially when it's remote, you do not have actual physical access to it. So first of all, let's go over what was done in 2018 very briefly. I'm sure you all didn't see AT&T today enough, so let's talk about AT&T a little bit more. So we're very thankful for our partners at AT&T and at Intel. Together we rose to the challenge to create this spec, which I believe you all know, Universal CPE. And it was defined by Intel and AT&T, built and designed together with Silicom. And we defined a few sizes. And these are, you can find the source here. It's a few talks over OCPE from John Gibbons and Dustin Grant. Now, we're very glad to report that execution is in progress. We've already contributed the first one, which is what we call the extra small. And by the end of this year, we'll be contributing all of the designs, which include a Broadwell DE design and Skylake D design. Now, what's interesting about this is the fact that if you do not remember the spec, the compute is modular, meaning you can actually go from one compute to the other without changing anything else about the design. And the front is completely modular. So you can add a switch, you can add, people mentioned GPON, and we'll get to the different modules that we can add a little bit later on. But it's completely modular. So you have a lot of options. I did put the call to action here because I wanted to define what is it that we're actually going to look you to do or to contribute. And we're looking for more ideas about how to take FPGAs to the next level, how to take modules to the next level. We're looking for feedback from the community. What should we be doing? What should we be focusing on? And are the ideas that we're going to present acceptable? And basically just give us your best shot as far as feedback. Would love to hear that. So as you can see, this will be online later, so you can go on and see the products. Again, they're all on our website already. So a little bit about the modules. We started off with the most basic modules you can think of, networking, and we have most of them already. So PoE, non-PoE, all the way from 1 gig to 25 gig and different form factors, so some fiber, copper, and so on. On the management side, we have no BMC, the 8-speed BMC like OpenBMC, and we have our own BMC, which I'll be discussing in a second. The next in line are, as some of my colleagues already mentioned earlier today, we're talking about GFast, GPON, 10GPON, OTN, and our main focus is FPGA, because for the others, there are some ASICs out there, or at least some solutions. For FPGA, it's a trickier situation, and I'll get into why that is tricky in a few seconds. So we're going to be focusing on the FPGA side, although as you can see, there's plenty here that we're focusing on as far as modules, and we look forward to hearing your feedback. But before we do that, let's get into the BMC. So as you know, OCPE has OpenBMC. We have defined together with AT&T a design called MicroBMC. Now, why is this BMC different? It's based on ARM, and the idea is that you'll actually have a small CPU managing all of your management. So towards the inside, it's very simple. It's an IPMI device. It's going to have Redfish, so pretty standard. But towards the outside, it's completely encrypted and secured. So just like a remote secure device, you'll open an IPsec tunnel. You have to have key exchanges, either a call home service or some type of authentication service, and only then would you be able to approach. And the idea is to create a world in which even if the device is remote, only the person that installed it can actually handle it, or somebody that has that key and it can authenticate every time it comes up. So that's part of the service, and even more so, you can send a blank box and it will only load after you do the call home service. So that's a little piece of what we're doing, and this is already available, by the way, and we're going to continue and build more layers of security on top of that, and I'll get to that in a second. So what are we actually doing in 2019? So we have our ranges of CPEs, all the way from the very tiny cell, all the way up to almost data center, I would say far edge. And we're focusing on a few different implementations. So of course, you've got your WAN connectivity, so you need a bigger pipe going out. You've got your SD-WAN VNFs that are connected, and you need to support them. And as I said, you need to support on the other end, the LTE, the GPON. You have to be, or the OTN, able to connect to all the devices that you have deployed. Now, on the software side, we're very lucky that Intel has brought some devices that we can use, like the DPDK and NAV SDK. And we're connecting that to our micro BMC and to Open RAN initiatives. If you don't know Open RAN is, together with FlexRAN, the idea is that Intel and the industry are talking about how to build a box which is actually supporting both RAN and LAN in the same box. How do you go from data center to edge and back again? So those are some of the initiatives. And today we'll be focusing on the far right corner, or far left for you guys, accelerators. So how do I do accelerators, both if I want to connect to my network, like my data center, and handle different workloads? So this is what we're proposing. I've got a picture here of one of our CPE boxes. All of them have expander slots for PCIe. And then you can take FPGA cards, PCIe cards. Intel has a range of them. There are others that have CPE cards, CPE-enabled cards for such a design. And the idea we're offering is to create a standard for how you inject cores into them. Meaning, we have an engine that we've built that we call Bring Your Own Core, or BOIC. And inside, we're expecting people to write their own cores and to inject them into an existing NIC design that sits inside the CPE. Now, there are two ways to do this. There's an existing design from Intel that is FPGA plus NIC that basically allows you to use the standard stack using the NIC, and then the FPGA is a bump in the ride that can add a core. And there's just an FPGA-only design where you would have to do DMA to the host or some set of drivers to the host. And what we're seeing is this. First of all, as soon as you have that, there are some cores that are already available. So we have FEC for RF signaling, optical signaling. We have Open RAN from different vendors. You've got ASOX, you've got Altiostar. You've got plenty of people that do that today. And what we're aiming at is higher functionality of, for example, P4. We have a partner called Netcope. They're experts in P4, and we've integrated their core into our core design, which means that you can actually do telemetry, segment routing, IPv6, all inside the FPGA while it's inside the CPE. So you add a lot more functionality when talking to a distant DC, or even if the DC is close. You'll be able to arrange that as literally a natural part of your fabric to just connect. Of course, there are other things to come. AI, ML, everybody's talking about that. So how do I, for example, get a lot of IoT devices and try to analyze what's going on in those IoT, behavioral changes, networking stacks? So of course, these FPGAs are also aimed at all of those type of higher-end compilers and analytic devices. But for now, I would like to keep it simple. So this is the design that we already have. So the orange parts, or off orange a little bit, are what we already have designed. And this is basically a NIC engine that does 200G towards the host, line rate. And it could do timestamp. It could do TSN support. So it has the ability to sync to networks, also time-sensitive networks. And what we're saying is we're going to leave a light on for you, a door open for you. We're going to define, and it's already in some of our specs open, a clear block that you can design to. And our hope is to create an environment or even an online shop where people will be able to go online, choose a core, dump that core into their existing design, and have a new ability available to them. And this could be also something that you can replace while you're building. For example, if you want some site to act differently than it did yesterday, you'll be able to log those cores and connect those cores without changing the actual hardware. So there's a multiple DMA engine here. As you can see, it connects directly to DPDK. So any application over DPDK, like VNFs, can very easily access it. And the next stage for us is to create a fully functional driver with SRLV, VirtIO, and so on. It's ongoing work with Intel. And this is the main idea. The main idea is to create really something that anyone that wants to develop their own core, or even choose a third-party core. You might want to choose DPI, or as we said, something that converts RAN to LAN, or any 5G type of core, and you would say, OK, I would like to integrate that. We can help you with integration services to get that going on the FPGA. So I'll jump ahead, although I'm sure there are plenty of questions on this. I'll jump ahead, and we'll get to the questions later. So what else can I do for security? And the answer is this. We're deploying a large variety of small footprint security devices. And when I mean devices, I mean solutions, because the footprint is going to be still a dual-core ARM or more. So you can do a very low-end Atom, you can do a dual-core ARM, you can do any sort of very low-end device, and you can get up to 1 gig on the very low end of performance and security. So we already spoke about the micro BMC, and that's just remote secure access. After that, we have the micro firewall, which, if some of you know pfSense, there's a company called NetGate. They are sort of the masters of pfSense, and they perfected a pfSense core that can go on top of this tiny device. You can see the smaller version of it as a look-aside or as a remote device below with 2 ports. And they can actually get up to about 500 meg on it. And the next step after that is something we're going to deploy very soon, which is Edge Firewall. Edge Firewall is actually same footprint as far as the hardware, but it can do layer 7 analytics of applications, and based on that, make routing decisions based on ACL rules. So if you think about it, it's as if you have parental controls over your remote device. You can tell it where to go, where to not go, limit the bandwidth for certain websites, make sure that your device isn't acting out of band or doing some BitTorrent stuff that it's not supposed to do. So that's definitely another piece of it. And I'm happy to say that we're now working with another partner called PFP Cyber. And if you have questions about that, Steve, can you raise your hand a little bit? So Steve will be able to answer you since he's from PFP Cyber. And the PFP Cyber solution offers you another layer of security. Their solution is able to analyze the power management of the board, and based on that, make an assumption on, is there something that's not working as it should? So they compare it to their AI engine, and they can basically say if something has been added to the board physically, or if some component is not running as it should. So here you go, another layer of protection over your edge. If somebody is tampering with your edge, you can remotely run this service and make sure every day, every month, make sure that nobody is tampering it with actively. So that's more or less the type of offering that we have in the works. We're definitely looking out to you guys to give us more ideas of what can we do to better protect the remote devices that we don't have any access to. So we're definitely interested in getting feedback about that. And if somebody wants to test the stuff already existing, that's great. We're going to build a forum that will be discussing the micro BMC and the security tools very soon, and we'll, of course, share that. This will be an open forum for anybody who wants to deploy these, to talk about features, to talk about what's missing, to contribute code. And again, we're trying to make this as hardware agnostic as possible. The only leading idea is to be very, very low footprint, extremely low footprint, because we know the edge needs those extra cycles. So that's more or less what I wanted to share with you. And now, if there are any questions, I would gladly answer them. Yes?
So you define edge as premise fundamentally, or because we look at sort of multiple edges with premise being one, and then maybe base station aggregation, central office. So do you use the term edge for all those locations?
That's a very good question. Actually, I've been taught recently there is far edge, near edge, medium edge. So what we're saying is this. When you change the hardware inside, you can actually go all the way from a very small, medium business like a McDonald's, all the way up to a large enterprise with the bigger box and maintaining the same features as you go. And I think that even if you think about the presentations we've heard before me, there's even a little bit of trickling effect towards the DU and the BU. Because people are saying, okay, wait, I want to have networking all the way to my radio-controlled units, and I want to secure it all the way there, and suddenly Ethernet is trickling down all the way there. So you need to secure that remote device now. So we believe that this design will trickle down all the way to maybe the unit connecting directly to the radio units. That's why we're offering some RAN activity, and all the way up to something that really connects to your spine in your data center. That's why we have P4. Anything else? Okay, thank you. Oh, sorry.
I had a quick
Please.
question. Meaning, I know you were more focused on the FPGA addition. I was kind of curious, meaning you had the 10 gig PON and the GFast. What is your idea? Meaning you don't have to go into too much detail, but I'm just trying to understand what is the scope here.
I'm very glad you asked that. You couldn't have asked a better question. Look at my next slide that I had on backup. So we're basically envisioning modules to go in there, like this one. This is a GFast module, and as you can see, it's very easily converted into one of the modules that we already have in the system. So the idea is to basically call out to the community and say, if you want to design a GFast module, or a GPON module, or even a voice module, which we're doing already with some partners, you're more than welcome to. We'll give you the spec, and the spec will be online, and you can just design to that spec, and you can add it to any of these universal CPE devices. Does that answer the question? No, it doesn't have to be. It could be ASIC. This one is an ASIC. So you've got companies like RAD and their counterparts, so Sienna, and those guys that do voice. You can actually say, hey, RAD, this is the spec. This is the size. Please build your voice for this. And then you get a voice module. So we're already working with a few partners on this, and we believe that this will be a very easy way to integrate it. Sure? Yes, please.
Question for your GPON module. And if you put the GPON module or 10 gig module into your uCPE box as a PCIe slot, will that conflict with the GPON presentation that was done just before yours?
Not necessarily. It's solving the same problem in a different way. Because I'm basically claiming that with modularity, you can answer that question. It doesn't have to be a totally separate box. That's the beauty of it.
No, I'm talking about like this one uCPE from AT&T, and then the first one also from AT&T. That one is GPON. This one also GPON with modular stuff. So will that conflict with in the business model or something like that?
Well, I think that there are a few suggestions. Again, it doesn't. This box is a joint design that Silicom did for the OCP community and for Universal CPE. Again, it's a suggestion. You don't have to deploy that exact box. Maybe in some scenarios you will. Some scenarios you might feel like a fully populated GPON or fully populated, as we said before, CPRI and stuff like that, like the cast that was here before. That might be a better solution. But all I'm saying is, if it's a unique use case, this box could do it in a modular fashion. Anybody else? Okay, thank you.